This is Jennifer Martinez, and welcome to Chapter 2, Linear Functions. Section 2.1 on page 28 of your class notes notebook is called the Introduction to Linear Functions. They start with an exercise that you can try if you want, but let's go ahead and do that together since it's the first exercise of the day. But you can pause at any time and try it first and come back. A pizza costs $9 plus $2 for each topping. So let's fill out the table. There's two ways to fill out the table. One is to just go for logic. So initially, when you have 0, we know it's going to be $9 because it just costs $9. So if you have 0 toppings, you still have to pay $9 for the pizza. If you have 1 topping, then you're going to have $9 plus 2, so that would be 11. 2 toppings, another $2, that would be 13. So I'm going to look at this one. This one is 9 plus 2 times 2 is another way of getting that. And then finally, 3 would be 9, another $2 would be $15. Another way of looking at that is 9 plus 2 times 3, since there's 3 toppings. You can see that that's also 15. So you can fill out the table and then use that table logic to come up with a formula. Sometimes the table helps you come up with a formula. There's not much room in here, but the formula is C equals, I'm going to start with C equals because they want a formula for C. I'm going to do what I did up here. I took the 9, I added, it was always $2, times the number of toppings. T was the number of toppings. C is the cost. The other thing you could do is come up with the formula first. Do part B first, 9 plus 2t, if you see the formula, and then you can find your table by just plugging in a 0, a 1, 2, and a 3. Part C you could try. It is finding the rate of change. That is from the last section. So let's go ahead and find the rate of change between t equals 1 and t equals 2. And they're going to call it the change of C over the change of T. If you recall, the formula in the last section said delta y over delta x, but the y is like our C and our x is like our T. In this case, and if you remember, it was f of b minus f of a all over b minus a. So if I look at between 1 and 2, so that would be the b would be the 2, and the a would be 1, and then I would look at the f's of those. So the f of 2 is 13 minus the f of 1 is 11. So it's a change of the c, 13 minus 11, over the change in the t. So let's do the same thing between 0 and 3. So that would be 3 minus 0. Now the b is 3 and the a is 0. So we still use 3. So f of 3 is 15, so I'll use that one, minus f of 0, which is 9. So that's 6 over 3, which is still 2. Let's graph the function. To graph it, I'm just going to plot these points. So 0 for the t, this one's the t, and this is the c. The horizontal is always the first column. The c is always the second column. 0 is 9. 1 is 11, so in between the 10 and the 11 there. 2 is the 13. We're in between every time, aren't we? 3 is 15. If we connect those, you see you get a nice line. So this is an example of a linear function. A linear function is a line. So first of all, they're going to be lines where the rate of change is the same no matter which intervals you pick. It's a constant rate of change. And you can kind of see that here because for each time they're going, right, if I look at the numerator, it's the change of the y. And the change of the y is always the same for the same change of x. And when they're linear functions, we're going to call this rate of change the slope. We'll see that on the next page, which sometimes they call m for slope. M is, in German, slope is starts with an M. So that's where they got the M from. Okay, so what we're going to do here is look at the idea of the slope. So if you notice, this would be the subtraction from here to here, right? 11 minus 9. So that's kind of like a rise. And then this right here, well, we did it between 1 and 2, but if I did 1 and 0, it would be 11 minus 9 if I looked at these two. And that they're going to call the run. If we did the part C that I did, you rise 2, right? 13 minus 11, that was the 2, and then we ran 1. So sometimes this rise over run, this is the rise, this is the run, is a visual representation of the slope. So sometimes they'll call change of y over change of x. I like to think of it sometimes as the rise over the run, which we just saw was going to be labeled m, the slope. So go ahead and try to do the same thing for exercise 2. For each function, fill in the table, and then find the rate of change over some interval. It really doesn't matter which one, because these are going to be examples of linear functions. But we'll see that in a second. Choose a starting x and an ending x that are different than your group mates. Well, we don't have group mates here, so you can go ahead and pick any two, even if I pick something different. So go ahead and try that and come back when you're ready. So here's my chart for part A. Plug in a 1, plug in a 0, a 2, and a 3. Which 2 points should I pick? I'll just pick the first 2 for easiness. So I picked the first 2. So I did the change of the y, 17 minus 20, the change of the x, and I got negative 3. Part B. Plugging in a 1, you just get a 7 over 2. Plug in a 0, 0 times anything is 0. 2, the 2's cancel. I'll just show that one. 7 over 2 times 2 would be g of 2. And this would be over 1. It's 14 over 2, or the 2's cancel, and you get 7. For this one, nothing cancels. So you get 7 over 2 times 3 over 1. So it's 21 over 2, which you can use your calculator and get a decimal if you want. So obviously, if I'm going to find that rate of change, I'm going to use this one and this one. You can use the fractions if you want. Go ahead and try it. You will get the same answer. But just out of easiness, I'm going to say 7 minus 0 over 2 minus 0. Sometimes we'll denote this as y2 minus y1. I did that very first day that in section 1.4, right? Because this is like the f of b minus the f of a, the y2 minus y1, all over b minus a, where x2 equals the b and x1 equals the a. So if you like this notation better than theirs, that would be fine. But you can see here that the delta y over the delta x is going to just be 7 over 2. You can leave it like that. That's a great way of writing it. Or you can change it to a decimal. Okay, let's look at exercise 3 on the next page. Before we start exercise 3, there's where they define the m and the b. Linear functions can be written as f of t equals b plus mt. If you go back to the page before, if you notice, that's how all these were written. Even this one, because it's like saying 0 plus 702. Right? We have a constant and just a plain x or a plain t. So it turns out that this is the general formula for constants m and b. You might have seen this formula if you're using y's and x's, mx plus b in your past. This is the same thing. The book just switches these and uses a t instead of x. B is called the initial value. We'll look at that for exercise 3 down here. And m is the constant rate of change known as the slope. I'll just put it here that we're going to see in the next section. But m is the constant rate of change, which is m, the slope. The amount f of t increases or decreases when the delta t changes or the delta x changes by 1. So if we look at here, let's look at p of 0 just to see this definition here. If I plug in p of 0, we get 30,000. We get 30,000 because I'm going to plug in 0 right there. And that would be times 0, which is just 30,000. That is the b, right? F of 0 is called the initial value. This is the initial value. It makes sense because in exercise 3 it says the population of town t years after it's founded is given by this formula. So t equals 0 means right when it was founded. So this would be is the, in this case, initial population. I'm just going to rewrite it here. It means that the initial population of the town was 30,000. You can practice. Go ahead and find P of 1 and P of 2. And after you find those, you can pause it and see if you got the answers correct. So here's part A. P of 1 is 32,000, and here's the work. P of 2 is 34,000. Okay. Let's go ahead and find the rate of change. So I'm going to look at the changes of the y, so that would be 34,000 minus 32,000, right? The f of p of 2 minus p of 1, I could write. Notice how that is 2,000. That is the slope. That is the rate of change, right? So it turns out that the rate of change is always the number right in front of the variable. Doesn't matter which order it's written, but it's right in front of the variable. So this tells us the slope. And what are the units of the slope? Well, the y was the population per, what was it? T was in years, right? Because this is population, this is years. So we know this is a rate of change, which tells us that the town's population is increasing by 2,000 people every year. So that is what part B is. What does the 30,000 tell you? It's the initial amount. And what does the 2,000 tell you? And it's the rate of change. So try exercise 4 and go to the next video for the solution.